Economic order quantity is a mathematical model used in inventory management to determine the optimum order quantity that minimizes the total cost of ordering and holding inventory. EOQ helps businesses balance the trade off between ordering cost and holding cost, ensuring that inventory is replenished at the most cost effective level. The key components of economic order quantity or EOQ are demand, ordering cost, and holding cost. Demand is the number of units a company needs to fulfill over a specific period of time. It's typically a year. Ordering cost is the fixed cost incurred every time an order is placed. It is regardless of the order size. This could include costs such as processing, shipping, and handling. And last but not the least, holding cost. Demand is denoted by D, ordering cost by S, and holding cost by H. So last is holding cost, the most important component of EOQ. It is the cost to store and maintain inventory over a specific period of time, that is typically a year. This can include, let's say, warehousing, insurance, depreciation, and the list goes on and on. The formula of EOQ is this: under root 2ds by h. D is obviously demand. This is the annual demand of for the product. S is the ordering cost per year, or better be per order, ordering cost per order. H is the carrying cost, or you can call holding cost per unit per year. And this complete term 2ds, this represents the total ordering cost over a period. And H is obviously the annual holding cost per unit. So EOQ, this aims at minimizing the total cost. This total cost, it includes both ordering cost and holding cost or carrying cost. So this is why EOQ is so much important. And if you can recall our previous slide of FSN, yeah, see, this non-moving items, they have to be controlled in order to reduce the holding cost. So if we can apply EOQ model for these non-moving items, definitely our inventory cost will be reduced. Now let's take an example to understand How EOQ model is made. So we know the formula for EOQ is under root 2 ds by h. Let's say, for example, a company sells 10,000 units of a product annually. So here D is 10,000, that is the demand. The cost to place an order is $50. This is the cost to place the order. That means S is $50. That is the ordering cost. And the holding cost per unit per year. This is per unit per year. This holding cost H is $2. So when we apply the EOQ model, when we put everything in the formula, we get under root 2, yeah, under root 2 into 10,000, that is the demand, into $50, that is the ordering cost, divided by $2, that is the holding cost per unit per year. This is per unit per year. So this is coming up to be 707 units. This means the company should order 707 units each time to minimize total cost. There are certain limitations also to the EOQ model. See, it's not possible to always have benefits of any model, benefits of any particular process. There are demerits also, there are certain limitations also. So let's discuss certain limitations of EOQ model. The very first limitation is the constant demand assumption. EOQ assumes that demand is constant throughout the year, which may not be realistic in dynamic markets. Even in a single week, demand can change, or even in a single day. Second is fixed cost. EOQ assumes that ordering and holding costs are ordering cost and holding cost. They are constant, which might not be true in all the cases. Thirdly, EOQ has a single product focus. EOQ works best for single product inventory system, but may not be effective in complex multi-product scenarios. So for multi-products, EOQ is not at all suitable. And finally, the lead time. EOQ does not account for lead times.